Now in Unit 8, Lesson 2, Arithmetic and Geometric Series. Not sequences, series. This is a follow-on to it. Now, what I want you to do is, if you don't already have your graphing calculator, please grab it. Or if you're at home and watching this on a separate computer or maybe a tablet, bring up Desmos, one of the two. Okay? Again, during class, you will have access for tests and quizzes to a graphing calculator. You will not have access to Desmos in class, just because I'm not going through all day trying to limit it and just Desmos. Okay, so let's get started without further ado. A series. Go to the set in your packet that you have, find the page where it has main ideas, questions, and it says series at the top. All right, if you have to, pause the video and find it. Now, here, a series, it's the sum of the terms in a sequence. So a series just says you're adding everything together. If I've got the sequence 1, 2, 3, 4, the series is 10. That's 1 plus 2 plus 3 plus 4. 1 plus 2 is 3 plus 3 is 6 plus 4 is 10. 3, 6, 9, 12, dot, dot, dot. Dot, dot, dot means it keeps on going for infinity. Well, if my numbers keep getting bigger, every number is 3 more than the previous number, and it goes on forever, then I get infinity. Now the next one's kind of interesting. I have 1/2, 1/4, 1/8, 1/16, dot, 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 which means it goes on forever. But this one, this sums to 1. This is a special one. This is called an infinite geometric series. We're taking half of everything. Every time you have a new term, you take half again. So your number keeps getting smaller and smaller and smaller until you're basically adding 0. I put a star there because we're going to look at infinite geometric series later. Just suffice it to say that a sequence is a list of numbers. A series is when you add that list together. Now, we're going to start by looking at partial sums. A partial sum is S sub n, the sum of a specified number of terms. You can start with the first term and add, you could add the first 10 terms, or you could add terms 3 through 7. You don't always have to start at the beginning. Now, if it says, like here, to find S sub 9, finding S sub 9 says I start at 1 and I go to 9. If I don't give you a starting point, you're starting at S sub 1. Okay? So, for these, find, if it says S sub 9, notice here I had to finish out the series or the sequence before I could add them all together. So go ahead, pause the video and try 1, 2, 3, and 4. And numbers 1 and 3, I did sort of finish out the sequence for you. You brought it back? Great. 45, 49, 91, 11 over 6. Ooh, 11 over 6. How did you get that? Well, if you got a calculator, not a big deal. If you don't, remember that you had 1 plus 1/2 plus 1/3. You need a common denominator, which is 6. So you had 6, 6 plus 3, 6 plus 2, 6. 3 plus 6 plus 3 is 9 plus 2 is 11 6. Okay? And notice I didn't have to add anything here because I was only asking for S sub 3. That's series sub 3. I don't want an infinite number, I just want a specific number. Now, summation notation. This is woohoo! So good, because you can do it in the calculator. Now, it's crazy. It looks Greek, because it is Greek. It's a way to represent a series using the Greek letter sigma to denote the sum. At the bottom, it tells you the first term. Because remember I said you don't always have to start with 1. In this case, I'm starting with 1. N equals 1 up to 5. 5 is the last term. 2n, that's the formula for each a sub n. Okay, so this is the formula for the sequence. This is telling me to add them all together. Now, to find the sum of that series, that means I have to start out and I first plug 1 into this formula. 2 times 1, okay, is 2. And then I have to add that. Then I plug in a 2. 2 times 2 is 4. Then I plug in a 3. 2 times 3 is 6. Then I plug in a 4. 2 times 4 is 8. Then I plug in 5. 10. And then I add all those numbers together and I get 30. Whew. That could be a lot, right? It could be a whole lot. I don't want to have to do that all the time. And I don't want to have to do that many calculations. First off, the probability is high that me and my fat finger disease will make a mistake. Okay, fat finger disease, I keep pushing the wrong buttons on the calculator. Now, how do I fix that? Well, I can grab my calculator and I can turn it on, clear it out, and I can do math, and then I'm going to go down, 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 down. Oops, there it is. Math sub 0, summation. Click on that. Notice I've got my sigma. Now here where it's flashing, I just let that be x. In this case, I want x is equal to 1. And then I'm going to up arrow, and I want the first 12 sums. And then how do I get each term in the sequence? Well, I do x minus 1. Right? Notice this looks exactly like this, except I used x instead of n. Now I just press enter and I get 66. The calculator took care of plugging in 1. 1 minus 1 is 0. Yay. 2 minus 1 is 1. 3 minus 1 is 2, and so on all the way up to 12. That just becomes very tedious. The calculator will do it all. There's your answer. Here, I've worked it out. I've found the sum of each series. I've plugged in all the numbers. Here, we're going to look at Desmos. Okay, so here's Desmos. Now, when you're looking at Desmos, you go to Functions, Summation. Notice n equals. Well, let's go back and let's see. We want from n equals 1 to 7 of negative 3n. Okay, so I come back here. So n is going to be equal to 1. And I want to go until 7. And then I'm going to put into parentheses negative 3n. And notice here I can use n because they start out with n. And I jump on the outside. I don't even have to hit enter. It just automatically tells me it's 84. If I kept adding operations inside the parentheses, it would finish it up for me. Okay? But there's summation notation in Desmos. Again, you just click on Functions. It's under Miscellaneous, and there's your summation. For your calculator, it's Math, and you go all the way down here to sub 0. You hit enter, and same thing. It's all there. You just plug things in. Okay? Not bad, right? So, that's it. There's our negative 84. Now, and I already said, what if you have to sum a large number of values? It could become tedious. You can use your calculator or Desmos. If you want to, you can pause the video. Oops, move the thing here. You can take a screenshot of this. I show the TI-84 calculator coming down to sub 0. On Desmos, you go to Miscellaneous and the summation. Fill it all in. Again, this isn't part of your notes. This is something I'm showing you how to do on the using technology. If you want to, pause the video, take a screenshot of this. Okay? All right, moving on. Flip that page over, the series page over, and you have a bunch of problems to try, 7 through 13. This shouldn't take you long, but seriously, go through, pause the video, and do it, and then I'll show all the answers. Reason I want you to do this, do it on your calculator, and then if you want, go back and do it with Desmos. But you need the muscle memory. You need to do it a number of times so you remember where to go and how to do it. If you just do it once, you're going to get on the test and you will sit there and stare at the test and want to ask me, Miss Whalen, where do I go on my calculator? And if it's during the test, I'm going to have to say, I'm sorry, but that's part of the test, is being able to correctly use the technology aloud. So, practice. Pause the video. You back? All right. So, 7, 8, 9, 10 must be a big one. 11, 12, 13. Hopefully these weren't bad and you got them easily. It's just a matter, again, of knowing where you're going on the calculator and where you're going on Desmos. All right? Now, in your packet, flip back towards the beginning. I want to say it's 1, 2, it's the third page. On the back of the third page, you will see about a third of the way down, it says Arithmetic Series. Go to that spot now. You there? Great. Recall that a series is the sum of a sequence. When finding the sum of an arithmetic series, use the following formula. Notice I said it's on your SOL formula sheet, so you don't have to memorize it. First thing you always have to do when you're doing a series, is it arithmetic or geometric? Write out the formula. Figure out what do you need, what do you have. So, notice on the formula sheet, there's the formula that you'll have. A sub 1 hasn't changed, it's still the first term. A sub n is the last term, because you're doing S sub n. These are all partial sums. Arithmetic series, there's no such thing as an infinite series. Now, number 13 has 2 plus 4 plus 6 plus 8 plus ... S sub 10. You only have 1, 2, 3, 4. You need A sub 10. Okay? So, in order to figure out A sub 10, plug in, sometimes you have to use the sequence formula. So I use the sequence formula to get A sub 10. Now that I have A sub 10, I have everything I need. All right? Notice within my series, I don't need the common difference, but I did need the common difference to figure out the sequence. After 13, try number 14. It'll be kind of similar. Okay? Here, S sub 8. I needed number 8. Now, notice that these are all arithmetic. So we're not doing any geometric yet. So you don't have to figure out which one's which. Coming down here to numbers 15 and 16. Quite honestly, with these, I would not find A sub 1 or A sub 12. I would just use the calculator, okay? Use summation on calculator or Desmos. On the other hand, if you're ever caught where you don't have access to a calculator, remember, you don't have to sit there and find the first term, second term, third term, fourth term, fifth term, all the way through. You only need the first term and the 12th term. Okay, in this case, the 12th term. And then you can, and n is 12, then you can find the series. So, oops, the main thing that this one here is doing is just showing you that, okay, even if you've got a summation notation, if you weren't allowed to use a calculator that had the summation notation on it or Desmos, you still wouldn't have to do 12 calculations, 13 calculations to get your final answer. Okay, number 16. Do it in two ways. Okay, first way, find A sub 1 and A sub n and n, then S sub n. Then use your calculator. Okay, you're back. A sub 1 is 13. A sub n is negative 31. How did I get n? Well, I found a sub 2. Okay, in this case, I found a1, a2. Okay, then I did a2 minus a1 is equal to n, and then I found a sub 10, then plugged everything in. And again, you can also do it simply by the calculator and summation notation. Now, geometric series, same thing. You get the formula sheet. A geometric series is the sum of a geometric sequence. To find the sum, use the following formula, where s sub n is equal to a sub 1 times the quantity 1 minus r to the n, all over 1 minus r, where n is the number of terms. A sub 1 is the first term, and r is the common ratio. Now, without further ado, let's look at these. Here's some examples. And again, notice on the left in blue, I have the steps that you would take if you didn't know it was geometric or arithmetic. In this case, these are all geometric, right? Here, you've got your formula, which I rewrote over here. Okay. You've got your a sub 1. You know your n. You got to find your r, so you just do 20 minus, or 20 divided by r is 5, and plug it in. Big number. You'd definitely be able to use a calculator here. Okay. Number 3, similar. I still want, in this case, okay, s sub 12. Number 3, s sub 12. Okay. Oh, and by the way, if you didn't already, you should have paused the video and jumped up to the series work, or the series notes. My bad. So sorry. And I don't know, on these it didn't have an s sub anything if you look at your list, so we did s sub 12 here. This one, which did I do s sub 7? I guess so. Yeah, s sub 7. So, and I don't know, oh, I know what it is. What happens when I haven't looked at this in so long? Okay. They give me a start, they give me an end. I have to figure out what that is. So I plug that in to the sequence formula. Okay. I don't know what that is. I can figure out what my ratio is. R was equal to the 6 divided by the 3. That's where I got the 2. The 3 is the first one. I don't know n. I do know my last term. So I need to find n. So that's what I was doing. I found n. Once I have n, then I know it's 12. Now I know I'm summing the first 12 terms. Over here, again, I don't know which term 2,916 is. I have to first figure that out. So negative 12 divided by 4 is negative 3. That's my r value. My first term is 4. My last term is 2,916. I can use that information to find out how many terms I'm looking at, which turns out it's 7, and then from there I can fill everything in. Try number 2 and try to figure out number 4. And then for 5, 6, 7, and 8, please just use technology. Pause the video, and you're back. Success? Super success? Pause the video and take a look at it in a little more detail if you need to. For 5, 6, 7, and 8, seriously, just use technology, okay? I'm showing you the work here, but use technology. And when I say use technology, I mean use the summation notation, either Desmos or your calculator. Make sure you know how to do both, or at least the calculator for in class. Okay? All right, infinite geometric series. This is on the back page, and this is the last part. Find the partial sums for each infinite series below. So, the sum of 1, sum of 2, 3, 4, 5, 6. This should be pretty easy to do. Now, a series that approaches a certain sum is called convergent. A series that does not have a certain sum is called divergent. And if you think about it, if I keep multiplying something by a bigger number, if I keep doubling it and doubling it and doubling it, it just keeps getting bigger and bigger and bigger. Never gets smaller. On the other hand, if I keep taking a smaller and smaller portion, then it's going to converge. I'm going to basically be adding 0 to it. So hang on, I thought I had found a video. Let me see if I can find a video of it. Okay, so I found this video on YouTube that I showed in class, and I want to show to you all as a way of explaining how when the ratio is less than 1 in a geometric series, that it actually sums to a finite amount, because you keep adding a smaller and smaller and smaller amount until you're essentially adding nothing. So here is this video. Hope you enjoy it, and then we'll be back and we'll finish up some of the examples and the problems. Okay? So here we go.
Infinite geometric series, a la Schmuck. Pepe holds the world record as the fastest pizza-eating human. Back in 2010, he inhaled 10 slices in 60 seconds. He was crowned the Pizza King and has held the record ever since. Those were the glory days. Glory days. But in the years since, he has let himself go. He can barely muster the motivation to make his way to the phone to order one. Still, he finds a way. One day, he is sitting in a pizza joint with some friends when he's challenged to a pizza eating contest by an unknown stranger. Pepe wants to relive the glory days, but he isn't sure he has what it takes. Just to be safe, he first eats half a pizza, then 1/6, 1/18, 1/54, and so on. If he keeps eating the pizza this way forever, long time, how much pizza will he have eaten in total? Well, first let's look at the numbers we have. 1/2, 1/6, 1/18, 1/54, and so on. Looks like we have something called a series, or actually, since we're assuming he'll eat forever, an infinite series. Let's take a closer look at the numbers and notice a pattern. Between the first two terms, 1/2 and 1/6, there's a ratio of 1/3. Between 1/6 and 1/18, we have the same ratio of 1/3. That is, we multiply the first by 1/3 and we get the second. Between 1/18 and 1/54, yeah, same ratio, the third. We can call this number 1/3 the common ratio, or R, of the series. Because the terms of the series are separated by a constant ratio, we can describe the series even more specifically as an infinite geometric series. Got that? Now that we've identified the type of numbers we're dealing with and the common ratio between them, let's get back to the problem. If we want to find the total amount of pizza Pepe ate, we should add all the slices together and find the sum. But wait, if he's eating infinite slices, how can we find a finite sum? Doesn't he keep eating forever and ever and ever? No worries, Pepe. The sum of an infinite geometric series has a finite sum, as long as the absolute value of the common ratio is less than 1. Think about that. In this case, the absolute value of 1/3 is 1/3, which is less than 1. As you can see from the series above, the numbers are getting smaller and smaller. 1/54 would go to 1/162, which is getting closer and closer to 0. See? So as you add smaller and smaller numbers, the addition of such smaller numbers doesn't matter much. Like he's eating a pizza the size of an olive after 5 iterations. Okay, so let's find that total for Pepe. The formula for the sum of an infinite geometric series equals the first term divided by the quantity 1 minus the common ratio. Let's see how this bakes out. Substituting our pizza values into the formula, we see that the sum will equal 1/2 divided by the quantity 1 minus 1/3. 1 minus 1/3 equals 2/3, so we're left with 1/2 divided by 2/3. Stop a sec, be sure you understand this. Instead of dividing 1/2 by that nasty fraction 2/3, let's multiply by its reciprocal 3/2 to get 1/2 times 3/2, or 3/4. There you go. That'll be 3/4 of a pizza. You can do that, right, Pepe? We have faith in you. Here's the water, and the Pepto-Bismol, and the barf bag.
Oh, pizza, I'll always love you.
Teeth sensitivity is so common, drinking or sipping
Okay.
hot and cold.
So, we don't need to hear about teeth sensitivity. Whoops.
Water. It
Nope.
feels like
We need to go back down to there.
somebody's poking
And
directly.
there's there. Nothing like trying to get back out of that. Okay. So, now, again, another thing you can think about is if you walk half the distance of a room and half and half and half, you're basically never going to get to the back of the room, right? So, a convergent series formula. S sub n is equal to a sub 1 times 1 over 1 minus r, or sometimes the a sub 1 can be written on top. The big thing here is you might simply be asked if a series converges or diverges. It converges if the ratio, the absolute value of the ratio is less than 1. It diverges if the absolute value of the ratio is greater than 1. Now, let's take a look. Here are some examples. Over here, I've got this if absolute value of r is greater than 1, divergent, no sum, else convergent. And you are going to do this formula. Try 11 through 16. No technology when infinity. When there's infinity, when you see a summation with the infinity, you cannot do the technology because you don't have an infinity button on your calculator or on Desmos. Okay? So, if you take a look at number 9, how do I figure out r? I do 1/4 divided by 1. Let's put that back up there nice and big. So I do 1/4 divided by 1 and I get 1/4. Therefore, I know it's convergent and I use the formula. Over here, I have 8/3 divided by 2/3. Well, that's the same thing as 8/3 times 3/2. The 3's cancel, and I get 4 as my r. Since 4 is equal to r, that's greater than 1, it's divergent, and there's no sum. If I keep summing forever, it's just going to get infinitely large. All right, pause the video and try 11 and 12. Okay, you're back. And how did you do? Both 11 and 12 are convergent. One has a positive ratio, one has a negative ratio, but the absolute value of both is less than 1. Therefore, they converge and you can use the formula. Remember, the way you find r is you take the second term and divide it by the first term. Now, 13 and 14 get a little funny. For 13 and 14, when you have the summation, you can't use technology. So what you have to do is you have to find a sub 1, and then you have to find a sub 2. Then you find r by doing a sub 2 divided by a sub 1. Decide if it's convergent or divergent. If it's divergent, then there's just no sum. Otherwise, you use a1 and r to find the sum. So, here, r is 1/4. How did I get 1/4? Well, I did, let's see if I can do this. I did -2 times 1/4 raised to the 1 minus 1, that's 0. Anything to the 0 power is 1. So a sub 1 was equal to -2. Then I came along and I said, great, now I'm going to make n2. So I've got -2 times 1/4 raised to the 2 minus 1. 2 minus 1 is 1, so that's -2 times 1/4. 2 times 1/4 is -1/2. Okay? Now I find my r value. Okay? My r value is -1/2 divided by -2, and that winds up being 1/4. So I know it converges, therefore I can plug all my values in. Okay. Now pause the video and try 14, 15, and 16. Remember, summation with infinity, there is no technology. Can't use technology with it. Okay? You're back. Did you get convergent for 14 and 35? Ooh, 15's divergent. 16. And have you noticed something when it's in summation notation? Ah, yeah, sometimes it's written so that you can actually tell what R is just from the formula, right? Alrighty, not bad. So now you have completed the paper. So what you have to do is time to practice. Go back to homework 1, enter it as sequences and series and do 15 through 24. Homework 2, arithmetic sequences and series, just numbers 16 through 21. There's just 5 problems there. And then number 4 is geometric series. After that, you're really good to go on, and the very last page, it says arithmetic, geometric, or neither, and work through that. That's got some applications and also forces you to decide if it's arithmetic or geometric before doing anything. Okay? Great. Excellent job.